So question 5, we're looking at work done in situations on two different blocks, block A and B. So to start off with, we're going to write the equation that you guys know for work. So we know work is equal to F times D times cos of theta. So in this question, we actually see that the angle that the force is being exerted on the block is in the same direction as the actual movement of the block. So we know cos theta in this scenario is going to be 0. So cos of 0 is equivalent to 1. So basically we can just take that out for the entire question because 1 times anything is just going to be itself. So we can cancel that off. And the only equation that we're going to be worried with is work is equal to force times distance. So now when we actually look at the variables within the question, we're going to have work on block A is force times distance. And we're going to have work on block B, which is also equal to force times distance. So we see that a force exerted on each block in both scenarios is equal to 1 Newton. And the only part that the two equations are actually going to vary from one another is the distance term. So with block A, we see that's pushed for a distance of 1 meter. And block B, we see it's pushed for a distance of 2 meters. So when we actually solve those, we see that work of A is equivalent to 1 times 1, which is equal to 1 watt. And with work done on B, we see that work B, and this time we're going to include units on it, so we see it's 1 Newton times a distance of 2 meters. And we see that that's going to equal 2 watts. So we see that the work done on B is 2 times that over the work done on A.